been doing. Last week, Amatai and I made a light fade in and out, and tonight, Butch and I are going to try to draw out the circuit diagram for this so we can make a schematic. And then, in our ideal world, we're going to be able to lay out a circuit board, and I'm either going to use that to make up the circuit to build our lights with, or I'm going to actually send that circuit board out to be manufactured by somebody and save myself the trouble and the nasty chemicals.
It
So,
is much easier and much cheaper these days to send them out.
yeah, that it is. There's what was that? Oh, Osh
Osh
Park.
Park.
Yeah, they're sort of one of the bigger players, but if you just go into Google and say PC board manufacturers near me, you'll probably get a lot of stuff that pops up on a map, and you're going to have to filter through. But living near Detroit, I found a lot of places that do complete assembly to whatever level of ruggedness you need, uh, including just a little. There's one up the road from me. I could walk to it. There's another one that's a short drive, and one that was on the way to the Meyer. So, anyway, let's get started. So, the heart of this circuit, and we're going to start by placing a symbol. And I keep going up to that menu, but I could actually do it by clicking over here on this menu on
Yep.
the right. I learned that about 15 minutes ago. I felt kind of silly for all the time I spent not doing that. So anyway, we're going to place our part. We've got to look it up. And the heart of this whole thing is an ATtiny 85. So AT25, the MU, I'm not sure the difference between the MU and the PU, but I know that ours are MUs. The ones that I've been using are the MUs, so that's what I'm going to grab. And we'll drop that on here. We'll just stick that right in the middle so we can go all around it. It's a little small, so we're going to zoom in. Now, the first thing you notice about this is this doesn't actually look like the layout of the ATtiny. It's not a perfect physical representation. It's got all the logic pins over here on the side. It's got the ground at the bottom and the power at the top. But that's okay. This is just a schematic. This isn't the circuit board.
And you'll see that with a lot of devices where they will arrange the signals for the pins in a more logical order. You'll see that these go PB0 through PB5 in a nice, neat order, but the pin numbers are 5, 6, 7, 2, 3, 1.
Yes.
So, so and on the schematic, you're more interested in the signals to make sense for you as you're drawing the circuit. And when you flip that over and put it on the PC board, then you'll be concerned about the physical layout.
Yeah, and we'll go into that physical layout in a little bit. So another thing we're going to need out of this, we need our LED, and I have there's a lot of LEDs in here, but I think this one here, which is just a generic LED, that will do for us. I don't think there's anything special about that one that I need to worry about. Well, I lost a little picture there, so we're just going to take it and call it good. Yeah, that one looks pretty good. And I don't like that orientation. Oh, a cleverer monkey would have remembered where he hooked that up, but I think I hooked it up to PB1. That doesn't really matter because these are we're going to drive these with 9 volts because that's going to be our power supply, and I obviously don't want to try to run 9 volts through my microcontroller. It melts the pins off. It's actually kind of impressive. So we have to add another part, and that is, and I chose this part. It's a transistor, and I chose the BC457. Mostly because I could get them really cheap. All right, so I need to actually put in transistors here first, and then I can. All right, this is going to go a lot better if I scroll the transistors and close down the other things.
And as you see, this application has a vast library of components.
It absolutely does. It's honestly kind of intimidating. I think this is an FET transistor. I'm not certain. I got a. Oh, that's not promising. 547, and that's because I am really great at typing numbers wrong. It's a special skill of mine. It is not a FET transistor. It's a BJT. Not actually sure what that means. You've got a little more experience with these sorts of things than I do, Butch.
Buy something junction.
Ah, okay.
I can't remember. We call them BJTs, and that's it.
That's fair.
It was 30 years ago. I had to know the actual words.
I'm just having to learn all this stuff. So, all right. So the ground on our microcontrollers on the
Bipolar junction transistor.
Okay, excellent. All right, the ground here. I want this. That is not what I meant to do. I need the pointy part of this. All right, that's gonna come down there. So that pin, that item marked as number 2 there, that is the base on this transistor. Which for our, correct me if I'm talking nonsense here, Butch, but that's our logic controller on the transistor, right?
Yes. Yes.
All right, and we can just put it right over here. We don't need a lot of wire there. All right, and we can do something similar with this. Now, this goes better if you select it. All right, and I need to change my orientation on that. Rotate counterclockwise. All right, that should set me up. That looks about right. So all my grounds are down here on this part, and so I can take, I think this is a reasonable thing to do, but tell me if I'm wrong here, Butch. I can take a bus here.
You can take a bus, or you can just use a ground symbol on each of those.
Okay.
So that you have a ground symbol there and a ground symbol on the LED. And in the schematic, it's connected to ground, and when you get it into the put it on the board, then it'll all, of course, be wired together. But
all right.
But you don't care. You don't care about that now.
Yep. Now I learned the hard way. This says place power. It's got a ground symbol here. It says place power port. What it's really going to do is put down a power port. So let me just put that up here. It does not. There is not a ground symbol available to us on that. I don't think. I will check here. Oh wait, no, there are. Okay.
Yeah.
All right. Now I actually want plus 9 volts up there. So I'm going to put a plus 9 volt up that way.
Okay.
There. That's a fine place for a plus 9 volts. And you can tell by watching this, I'm not greatly experienced with CAD software, but it is what it is. Okay, so let's drop a ground here. All right, and I don't know.
You want to use the GND one, not the Earth one.
Do I? Okay. Now, what's the difference between those two?
Subtle, but or when you put an Earth ground on there, you really need to have it attached to
an actual Earth ground rod.
The third prong in there in your stuff. And when you put the GND one there, you just mean the neutral for this circuit. And since this is all for our purposes a DC circuit, we don't care about that. But
right, but it could matter for other things. All right.
Yes.
All right, so those are all set up as ground. And I'm going to drag this collection down one. Oops, I'm going to make a mess is what I'm going to do. All got our hobbies. All right. And that way these are in line and it satisfies my desire to have everything neatly lined up. All right, so we need to connect our VCC there to our 9 volt power. And I also need to connect the collector side of the transistor to 9 volt power.
So that AT Tiny can run off 9 volts?
Oh, no, you're right. We got to put a power controller in there. That's good call, Butch. No, the smoke gets out fast.
I was about to be super impressed in the AT Tiny.
Actually, well, I don't know if the Tiny can. The 328s can. the ML328s, but this is not a 328, and I don't want to play that game. Yeah. Oh boy. There we go. All right, and folks, this is why we pair. It keeps us from doing silly things. I guess I want to drop a symbol still.
You would have caught it eventually.
Yeah. Anybody smell smoke? Yeah, I don't. This one might be tolerant that high. You could. I know for a fact you can run 328s, the common Arduino device. It will absolutely run off 9 volts. One of the reasons why they're so beloved is they're hard to fry. Oh, I'm trying to think of the component that I even need. The worst part is I know I've got a box of them somewhere, but I don't want to rummage them out right now to read the part number off of them.
Is your voltage regulator you're talking about?
Yeah, maybe there's just a voltage regulator thing down here. Thank you. I was having trouble with the voltage regulator turn. Valve
I can't remember. I'm having trouble remembering the numbers on it myself. I know it's an LM something something.
That's one of them. There's another. Let's see what it comes up with. Unfortunately, these things don't give me the.
Yeah, the AT Tiny can't take anything more than 5.5 volts.
Right, so we aren't going to give it anything more than 5.5 volts. Just. And the thing I'm thinking of is a little 3-pronged thing.
Yeah.
Well, it's going to be one of these things. It's definitely not that one, which is an 8-pronged thing. Oh no, that's a.
Huh. The 385 was what I was thinking of.
385. All right, let's grab that. They got the 384 and the 386. They're just trying to make us feel silly.
Yep.
I hate the 384. 386 doesn't look promising either.
Yeah, the 386 is.
If anybody out there on the chat knows the part we're looking for, a little 3-pronged monster, but I don't think there's anybody on our chat. What an inconvenient night not to have an electrical engineer hanging out in our chat.
We have the Googles though.
Yeah, that's what I'm going to have to do.
I've got it. Here we go. Oh, it's not going to tell me the thing there.
$78.05.
There it is, 7805. I knew it had an LM and some numbers.
Well, it's just the L7805.
Oh, the one I was looking at is LM, but that's okay.
Okay. Oh yeah, you're looking at the real nice ones that can do multiples, right?
It's still a 3-pin, but yep.
All right. So we've got this here. We can just put it up. Let me think where to put this. I like it right here. It's kind of awkward, but
when you're laying out the schematic, it's important to lay it out where it makes sense to you visually and figuring out whether signals are going and stuff.
Yeah.
When you put it on the board, you'll be more concerned about making the board as small as you can, keeping some parts away from the other, orientation of the traces and stuff like that.
Yep. So I'm going to put the 9-volt there.
And likewise, like with the ground, you don't really need to draw the wires there. You can just say,
yeah, that just
that's
goes
your
to a 9-volt.
Yep.
And this, yeah, and I'll have to redirect. Let me zoom out just a little bit and get a look at that, where that makes sense to go. So out's going to go to there, to there. It'll just drop in there. All right, let me get rid of some extra stuff.
So if you just put a name signal on your out, if that's going to be your 5 volts or whatever it is,
Uh-huh.
then you can drop another power pin there and label it as 5 volts, and that'll be the signal for it, the name for that signal. And then
Ah,
you can not have to draw the lines, but just put the input to the things at 5 volts. And
so that's one of these labels here, right?
yeah,
All right. I don't know if that did what I wanted it to do or not.
I'm not sure. There's a and there should be a way to both label it and name that the signal coming off that pin, and I think the label does that for you there, like that.
Yeah, and then I just draw another label here and attach it to that.
Yeah, or right on the transistor, because that's or wherever the 5 volts is going to go, and then
It'll go to the transistor and to. Oh, it only goes to VCC.
right.
All right.
So if you put a 5 volt, a label that says 5 volt there, then it'll indicate that those things are attached. Even if you, like if your schematic gets a little busy and you say, okay, this power is pretty much a thing on its own, I can just slide it over to the other side of this diagram, but
Yeah.
all your signals still are named, so they're going to connect up the right way when you go to the PC board.
Yep. All right. So I'm going to delete this wire here. And this goes to 9 volt. It'll be that same 9 volt, so I can just put a power block in there, right?
I think so.
I guess we'll find out. All right, that goes to 9 volt. Now I do have to draw an honest to goodness wire here from PB1 to the collector. I have to draw another, or to the base, and another wire from the emitter to the LED. So those are connected. And I'm gonna place a oops, percent V is a different symbol. I don't want to do that. All right, those are linked and rotate that clockwise. Okay, so that should be good. Everything's got its connection except this needs a power port. It needs a ground. All right. I think that's everything connected that needs to be connected.
Cool.
All right, let's put some labels on this stuff properly, though.
Okay.
7805, I want to make that. Oh, let's try to not drop a power port on it. Let's select the item. And let's change the properties here. Instead of U question mark, let's make this U1. And this one will likewise become U2. And this will become Q1. And this becomes D1. All right. So that's those. I feel like this is a swell time to save this. everything's got its labels. All right, now I just hit this little button that takes it to the printed circuit board, right?
Yes, and it'll do magic.
All right, and it did it, and it did it on a different screen. Here is the thing. Indeed, that was magic. The astute observer will recognize it is not the magic I was really looking for, but it is the magic I got. Okay.
But you see it recognized all your signals,
Yeah,
and it
everything's
looks like
connected, right? Pin 6 here is going to the base there, or to the, I hope that's the base. That's going to the
it's going
collector.
to
Yeah, and that goes
and your
to
and
power.
your
Yeah, and power isn't really drawn in here because pin 8 goes to 5 volts, and that's not there either.
is that on your schematic though?
Oh, pin
Go
8's
back.
not.
Go back.
Pin 8's VCC. Pin 4 is power. So yeah, let's go back up here. All right, 4 goes to ground, but I've not drawn a ground in here, but we'll have to do that. That's not a
So
big deal.
it should have drawn it for you though, because you put the.
Oh wait, this is. Oh, you know what? This is old stuff. This is old stuff. I had done this before, and I didn't have everything wired up right. That's
Okay.
what's going on here. So I am
So
going to select and remove.
now I don't know how in KiCad you tell it to regenerate that thing.
I don't either, but I think there's a thing we can do. How about we try deleting? Yeah, let's try
Okay.
deleting that. And now, if we do this, it might do the thing for us. Yeah, it doesn't exist. You want to create it? Yes. All right. It created it. I feel like I wanted to do more than that.
Is there nothing in there?
I'm seeing a whole lot of nothing.
Wow.
I'm seeing really advanced amounts of nothing here. Let's see.
So now we get to explore how to make it regenerate it from the schematic. There's got to be a button up there that does that.
Open schematic and a schema. Oh, this is a custom layer set, and I'm going to leave this custom layer set alone.
Yeah.
Because if I'm being perfectly honest, I really don't understand that stuff. When I take this,
Well,
thing,
it says that you've got 2 layers there, and your trace thickness is going to be 1.6 millimeters.
yeah,
So the 2 layers is one on each side of the board, and the way they'll end up trace width, which you probably don't care about too much at this point.
yeah, things are pretty low power. When I go to get this fabricated, I'm going to have to find a very patient fabrication house that can explain this to me in simple terms.
The they'll probably be very helpful. And if you go to the Osh Park page, one of the things it's got on its page is recommendations for layouts for various boards.
Oh, that's very nice of them. Okay, so this says we need to add a footprint to D1, and we need a footprint assigned for U1. U1's that 7805.
Mm-hmm.
So that one's fine. The D1's not quite right. That's going to be like screw terminal attachment because those are on leads. So we'll have to manage that one ourselves.
Okay.
But I think we can go add a footprint for.
Oh, I see you got to update PC from schematic. Cool.
Yeah.
So.
All right. There's all our stuff there anyway. Let's zoom in and see what that looks like.
I don't feel like it got the 7805 in there.
It didn't because it doesn't know what the footprint looks like for it. So we'll have to tell it. But this looks. All right.
Didn't put any, which it's okay that it didn't put any ground in there. We just need to.
We need to add a ground and.
Yeah.
Yeah. So it's labeled our ground here. It got the one connection that it knows how to do which is PB1, which is pin 6, to our base. So that's good.
Yeah, which means either I misled you with the labels, or there's something else about this program we don't know yet.
Yeah. I still have so few problems imagining that there's things about this I don't know. My ignorance knows no bounds. So I think the next step is let's put the 7805 on here, and we'll have to add a footprint for it. I brought that up on the other screen, so let me bring that over. Oh, I don't want to edit a footprint. What do I want to do? I want to assign a footprint.
I feel like you would have done that as part of putting the component on the
Yeah, I think you're right. So let's
board
go
there.
over here and do that. There might
So
even be something here.
how does it not have a footprint? We got it from the library.
Edit footprint.
It's got a size, it's got other things. What more does it need?
Yeah, that's kind of where I was going with that. Um, package. Oh, what's the standard package on this? Just a second here. I'm going to go look it up on Mouser because we do have the internets.
It is
All right, I don't actually know how to. And theirs are all Eagle CAD names, so it doesn't give me a name for this type of.
it is a it is
Oh,
a TO220.
thank you. TO through hole.
Dash 220.
I just keep scrolling down this list. We'll get to it. There we go. TO220. That's a 2-hole. We want a 3-hole vertical. There we go. Okay, so that one's there. Now, how do I say that that's the one to use? Well, now I feel stupid. Double click it. That's how.
Sweet.
Okay, so it knows that that's a TO220.
Okay.
We could give it a footprint for. We could give a footprint for this LED too. We could say
Yeah.
that it's going to be a screw terminal footprint. I don't know if that's the right thing to do, but it's what I'm going to try.
Okay.
Mounting equipment. Nope, not a DIN rail adapter. Terminal block. There we go. Alltech. I got a whole bunch of different types of terminal blocks here. And one's a 3. Yeah, that's 2. Okay, this is the type of terminal blocks that I can get easily. 5mm separation on the pins, and 2 connectors.
Cool.
That little thing. Oh, 7.62 millimeters. That's way bigger. All right. This is the sort of standard little terminal blocks that you can just order off Amazon, and that's what I'm going to use. Or Mouser or anybody else, I guess. All right. So that's his footprint. And now let's try updating this from... Update PCB from Schematic. All right, let's
Hey,
close it. It threw
there's
some
some
stuff on
line.
there. Yeah, okay. Let's zoom out just a little bit. Let's save this. We've got it to a point. I don't think it's a healthy point, but
It's got the pieces on there, though.
it's got the pieces, and that is a big step up from where we've been, so I will take it. I don't know if those lines represent actual traces or not. I think it's...
They do.
Do they? Okay.
So as you move those parts around, it'll keep these signals connected,
All right.
and then you'll be able to rearrange them, and then you'll find that this would probably it should do a reasonably job. You've got 2 layers to work with, so it'll have something to manufacture, but you can see your traces look kind of wonky, and I'm not sure how it demonstrates to you that some are on the top side and some are on the bottom side, but
I'll bet by color.
yeah, and I was trying to differentiate that color there and I couldn't see it.
All
So
right.
but you should be able to move them around and get the thing as compact as you want to do it, and if there's particular places that the components need to be on the board, move them there so it's presented the way you want it to be.
Yeah, and I need to zoom out. This board's way bigger than what I need, obviously. And I actually want this to be a small board.
Yeah.
So I want to, I'm doing this circuit for a fake pumpkin, and there's lots of room in there, but I also want to stick it in a length of PVC pipe and cut a couple of holes in that and have that looking at me out the bushes.
So there's the the physical needs for it like that, and there's also the consideration that the smaller it is, the cheaper it'll be.
Yeah. Yeah, they charge by the square inch, so
yeah.
I see no need to run up my bill. All right, so we're gonna have to resize this board a little bit, but that's okay. All right, now I don't know how I get it to drop those, and because I want to separate. 7805 doesn't need to be right there. I guess it doesn't hurt anything to be right there.
So if you are they kind of selected together, you mean?
Yeah. Okay, there we go. I just selected something else.
Yeah.
All right. I'd like to get that back just a little bit from the edge. I worry about it being out there. All right, there we go. I selected it. And now I can move it down here. All that stuff is really tight together. But I got my semiconductors nice and close to each other. I don't know if that's good or bad, but it is. Oh, my power. I need to put my power on here yet.
So you drop a pad somewhere and you'll say this is power. And there may have been a way to do that on the schematic to say power comes in here and let the the PCB magic do its thing, but you should be able to draw a pad on there.
Yeah. Yeah, and that needs to really be another screw terminal anyway. So that's.
So you may.
Could I just wire it through hole? I mean, I could.
Well, you could. Yeah.
I don't know if that's strong enough. I think I was going with the screw terminal because it's stronger.
Well, is it going to have much tension on it at all?
Yeah, this is the part that's going to get yanked around.
Yeah.
So better do that. All right. So it gets a screw terminal. The LED probably, it's not going to get yanked around nearly as much. Once it's in place, you probably tape it down and call it good. All right. So another screw terminal. I got to figure out how to do that.
There should be a library for this too, where you can get things and drop them on the board,
Open
name
footprint.
them and stuff like that.
Yeah. Symbols are different over here. What's that do? All right, nothing there. Nothing over there on that toolbar. But there's this whole thing over here on the other side. Highlight the net, display local rat's nest, add footprint. Add footprints. I'll bet that's it right there. All right. That, I'm sure, activated a window somewhere, but I don't know where it activated it. Oh, no. This is just like on the other thing. I just have to add things in here. Okay, so that's my LED. Actually, my LED doesn't need to be there, but let me drop this part over here. And, oh boy, what was that? That was a screw terminal. Yeah, that's not right. All right. Let's reposition this. I don't want this here. That I was thinking that was power, and it made more sense as power. Over here, this is the LED. And I'll have to change the orientation. If I rotate
So once you put
counterclockwise.
once you put the LED on the board, are you ever going to change it? Is it going to be a part that you swap out?
It wouldn't be a part that you swap. Oh, right. I see what you're saying. We don't need a screw terminal for it. We could just put that on a pad.
Yeah.
Yeah. Once you place that in whatever your location is, you don't really need a screw terminal.
That saves you some space too.
Yep. It will. So I'm going to change the footprint up here.
To the LED.
Yeah. This really just needs to be a couple of pads.
That's the power. That's the power regulator.
Well, thank you for keeping me from doing something completely stupid. It is one of my hobbies, but all right, that is not a terminal. It is.
Should be pads there somewhere.
Probably be in the P's, won't it?
Maybe.
Yeah, package, right to potentiometer. All right. Socket?
Nah.
Does not seem likely.
Does it have any holes or anything like that?
That could be. Let's see if there's. Got test points too. I don't think that's a likely one. Jumper. Yeah, heat sink's the closest we got, but we got jumpers.
That's not the same thing though.
No, it's not.
Is there a through hole or anything like that? Or something of those names?
I didn't see through holes, but I wasn't looking for through holes.
Valve, resistor.
Honestly, let's test the test points, see if there's anything in there interesting.
These are going to be kind of pads and not really holes, though.
Oh, this is a through hole. This is a drill.
Yeah.
2 pads, 1.33 millimeter. I think we only need a little. Oh, no, we need the bigger one. This is wire. Honestly, I think that'll work.
Hold on. I happen to have another circuit up here, one of their demo ones, and I'm going to find an LED on it and see what they gave it for footprint. I say I'm going to do that. They are all surface mount.
All right, I'm gonna go with that drill hole.
Okay.
I'll see what that gets me. I'm gonna try putting a pad on the 9 volt. Hey, there's a footprint editor.
You know, an LED, now that I see that, think about it. You go ahead. I'm going to research for a little bit.
All right. All right. Now I am going to save that, and then we'll see what KiCad does to me over here. Update PCB from schematic. Changes applied to PCB. So our U1 is present. Our LED stayed a screw terminal.
There should be a footprint library item called LED, et cetera, et cetera.
Yeah.
So if you go back,
our LED is not going to mount on the board though. This is something on long wires.
oh
I'm sorry, I didn't make that clear, did I?
no, I was thinking it would be on the board.
No, that one I had down. That one was easy. No, this is the thing on long wires so that you can sort of position the LEDs where they need to be for the eyes of whatever you're building.
Oh yes, that's why you need the screw terminal there.
Yeah.
Yeah, duh.
But I don't know if I need the screw terminals, what I'm thinking, because once you get them in place on your device, you'll leave them. But your battery mount, that's definitely not going to be the case.
Well, see, that was why I got confused. Is that when I asked that question earlier about once you put them on, connected them, would they ever change? Then, are you gonna put them on wires? Or are you gonna solder them to the board, or are you gonna attach them to? Would you ever change the wire, the length of the wire, anything like that?
Only if you're going to take it out and remount it in another device.
Yeah.
In another Halloween decoration, which I suppose you might.
So you might.
All right, let's leave that screw terminal there. Let's just drop another footprint on here.
I think you want to rotate that screw terminal though. Your screws are pointing at your. You want them probably pointing.
So the way these work, you see these little squares here? If it's the device I'm thinking of it is, that's the opening where you put the wire in right there.
Yeah, I was looking at the things that look like screw slots to the left of that.
Yep, those screw slots are above it, and they tend to be towards the back of it. Well, in any event, we can always turn the little device around if we need to.
So if they're facing where your chip is. And I still may be confused.
Yeah, and I don't want them facing the chip. I want them facing away from the chip.
Yeah.
All right. In any event, I think they're facing away from the chip. Is what I think. I'm not certain, but what I do know is that this one at the bottom of the screen is the ground, and if we just label things down here, this is. Mark, we'll just put a label on the board that this is the black wire and this is the colored wire. Then everything will be fine.
But I will say that if you rotated that 180 degrees, your traces would be prettier.
Yeah, they would. I'll grant you that one.
So my thinking there is if that image is correct and the screws are that way, then they're going to be facing your AT-Tiny right now, and you'll be trying to screw wires in.
Yeah, the actual device usually has the screws on the top.
Okay. Okay. So that's more representation than an actual image
Yeah,
of it.
I think. I don't know. I don't know. This is all.
Okay. That's good.
I don't know. We'll print it out and see what the traces look like, and I actually need to set this up for a 1-layer board. But anyway, let's get our 9-volt on here.
Okay.
All right, so there's our 9-volt. And our 9-volt's going to want. All right. I got a little bit of editing to do on this thing, and I'm not sure what to do. Well, maybe first let's pick the right control. Okay. And let's rotate this thing counterclockwise, and then rotate it counterclockwise again. And that takes it back more to how I think these things are built. And so we always like... All right, how do I put traces in? Route tracks, okay. Go from there to VCC is right here. And that track. Put a track from here. Ground is here. We end that track. All right, and we need to edit. We need to stop doing wire traces, and we need to go back to editing things. And this has properties. So this is the battery. That is its footprint. I don't know what that %R is.
Don't either.
Oh, reference is going to be 9V. That is plus 9V. Okay. That makes more sense now.
Cool.
Now, what else am I missing? The ideal would be you might need 2 LEDs. I don't know if I really need to put 2 terminal blocks on to support that, though. The two.
Why not? Oh, you mean because they're going to be on the wires that are way out there somewhere.
Yeah. Well, you can just stick the. Yeah, you just wire the two together, then put that wire in there.
And they're going to come on at the same time and all that kind of stuff.
Yeah.
Okay.
Yeah, if I was going to have them independently controlled, I'd have them set up differently. I'd also have more transistors. All right.
Cool.
This is actually not horrible. So we do need to put some text on the board. I need to change this board a little bit too. So that's a 2-layer board. If I ever do a prototype on my own, I can only burn 1-layer boards.
Yep.
So there was a thing here about board setup.
They have these neat.
It won't go less than 2 copper layers.
Yeah, no, two should be easy for you. Oh man. I'm digging in my boxes right now. So they have some nifty little prototype boards that are the board full of holes with two layers on it,
Yeah, the perf boards. I got those.
and have copper on both sides and stuff, so you can do things.
Yep.
So you can still do your two layers that way.
Yeah, and I'll use that for prototyping, but I'm actually looking to maybe have boards printed
Yes.
with the notion that a clever person could assemble these things, multiples of these things to make a really neat Halloween display, or make these up as kits that I can send out to people that are wanting to try out tech, but
Yep.
assembling from perf board's a different story than, well, I just put these on the marked holes and away we go. All right. Huh. That looks truly horrific if we go to, especially the way some of these things are routed.
Yes.
I'm curious what this will look like if we go to print it.
Does it? So have you used the route function yet?
I haven't. I don't even know where it is here.
I see there's a route menu up there, but I'm not sure which of the icon buttons. Um,
Route single track. What's it gonna do if I do that? Oh, that's actually for me to go and route a thing.
ah,
That's not what I
yeah.
want to do.
There should be some way for it to go do almost all the work for you.
Yeah, although the general rule I've always heard about these is don't use the auto router.
Yeah, but you can get it started for you, and then you can move them around as you need to.
Alright. Yeah, so it's getting really mad about all those tracks too close to pad. So all these things here.
Yeah.
So I'm not shocked by that, not in the least. Uh, so let me grab. It doesn't like that one. That one should be dragged there, I think is what it's trying to tell me. Anyway, let's. I don't know what it's bent about there.
Doesn't like it though, does it?
It seems really mad about it. Oh, you know what? I know what its deal is. Let me see if I can select that route. So what's happening? I drew that to the center of the pad. That's not where it goes. It needs to go right into there.
Okay.
I drew it to the through hole, basically. It does not like being drawn to the through hole. It wants to be drawn to the actual pad. For
Makes
which
sense.
I cannot blame it. My route editing, I don't necessarily know how to do that. Yeah, route editing seems to be a little bit of a challenge here. I wonder if I zoom in more, if that would make it easier to view things. Oh, I just selected it. All right. goes there. Oh, it wants to keep going to the centers of those. Huh. I have no idea what I'm doing. I'm going to just delete that route. Oh, that's not what I wanted to pick at all. Although it did occur to me that if I rotate this counterclockwise and shift it a little, yeah, look at all those routes down there. We're just going to delete those nasty little routes right there. And we're going to delete that route. We're going to delete that route. And we're going to delete that route. All right. Now I can grab him and I can drag him down here. Okay, let's delete those markers because we don't need those. And I don't have any say in whether or not those markers get deleted. All right, but it occurred to me if I put this here, square pads are ground, and I can run a route from here out to here, down to here, and over to there. No, seriously, I don't want to go. I want to go there. It's not having it.
Is your is U2 not aligned on the grid for some reason?
It's not. Good catch. Yeah, U2 is doing its own thing. All right, I think that's on the grid now. All right, so take that route from there. I'm just going to delete that route. I'll just draw a new route.
So folks watching may see us stumbling around, but recognize that this is like the first day we've used this tool.
Oh yeah.
We got a schematic drawn. We got things on a board drawn, and we get to play with them. And even though we're kind of fumbling around, it's vastly better than drawing them by hand on a drafting table and having to either erase or throw the sheet away when you say, yeah, that's not going to work.
Yep. All right.
So is that one not on the grid?
It does not want to go inside that pad. It wants this route to be outside this pad.
Huh.
But something neat that I did notice going on. I picked that. Oh, it's not doing it now. I'm just going to delete all these segments again because they're clearly not right. But see, when a segment is highlighted, no, it's not going to do it. Let me draw another route. So I draw from here. No, really, I draw from there.
Yeah, you don't.
All right, I picked that, and look at it's showing all the stuff that's connected.
Yeah.
All right.
That is.
Oh! I know what's going on. It doesn't think
Not,
that those things are supposed to be schematically connected, so it's like I'm not taking you there.
It's trying to save you from letting more smoke out of something, isn't it?
Yeah.
So
it's showing me where I'm supposed to go.
Yes. That works a lot better. So what do we need to put labels on those two pads so it knows what they are?
I think so. I don't know. It's definitely.
So do we need to put?
Oh, we need to associate that with the. Let's just go delete that object up there.
Yeah.
And we'll.
Is there a way to represent that on the schematic so that we can give it the right footprint and then it'll have signals and things?
Yep, that's what I'm thinking. So let's go out
Cool.
there. Okay, so there's our plus 9V. And I'm really hopeful that it seems to recognize grounds, so I'm going to assume that it'll recognize
So,
plus 9Vs. So we just need to go to properties, give it a footprint.
well,
Oh, it knows it's a terminal block, so I did something wrong. Let's go back out here, and we'll update from schematic. I'm having a shortage of terminal block of plus 9Vs.
so I'm wondering if we don't have our signals named right for some reason.
That could be. No, it got the grounds.
Okay.
Oh. This is really just a label, I think, but let's try putting a footprint on it. I feel like I didn't have the right thing before. I don't know. I'm definitely I'm out at sea here.
Yeah, we're experimenting. We'll figure it out.
Definitely spiking. Okay, both these have the same thing now. So maybe I have this feeling that they aren't going to play nice that way, but we'll find out. Because the plus 9V and the ground are separate things. It's not going to know what to do. Yeah, it's not even processing those. It knows that they're connected, but that's all it knows.
Okay.
All right, so we are going to have to. Well, you know what? We'll do that. We'll deal with that in a minute. We were having some pretty good luck with those traces.
Let's draw the other traces. We'll figure the rest of it out.
Yep, the drawing traces is going to make me happy. It wants to go there. That's good. That doesn't go anywhere else. That's the end of that trace.
So can you click on the white lines and have it draw something there, or are those really just
Those are just showing us where the connection is.
indicators? Yeah.
All right. So this needs to go. This is my VCC.
Yeah.
And that needs to go over here.
Cool. That seems like it's awfully close to those other two, though.
That was my take on it as well. Go up there, and then we'll take that in there, and that'll be happy. And I need to go from here to there. That's happy. I need to go from there. It's auto routing it for me.
Well, it's telling you can't cross those, because you are.
Yeah, I'm on a single layer.
Yep.
All right. It might be crazy, but it's what I got. Let's try it.
So
all we have to do is get our VCC in.
So if you took the center pin from U1 and took it around to the right hand side of the LED D1 from the LM780,
come around this way.
would that let those other two traces have a cleaner line to wherever they're going?
Can't hurt. Let's grab it. And that didn't come out the way I wanted it to.
Yeah, you may have to like delete it or something.
Yeah.
I don't know. Will it let you just grab it and drag it?
No.
No. Okay.
That would have been great. But yeah, that would let this line from here come right over to that.
Yeah. Does that leave the other one still having a more or less straight shot to where it needs to go? I think so. Yeah.
This one gets weird.
You'll need to delete that one before you route the the center pin on the
Yeah, that one's. Oh,
785.
right. We already knew that one was weird anyway. We didn't like it.
Yeah.
Yeah, I have no idea how we'll select that little monster. Okay, like that. And when we zoom in, some of the stuff's easier to see too. All right, that one goes, and that one goes.
I wonder if there's a way to tell it to select all the connected traces here.
Boy, that'd
Okay.
be really good. So
So
grab from there. If we go to here,
yeah, I don't think that goes there. Oh, maybe it does.
it does. There was a line and everything saying it does. So I think we're good
And
there.
then the other ground coming around from there up and over. Yeah. Okay.
All right. We've gotten rid of all of our really weird ones. And now
So what was the one we got rid of
that was
or
the
did we?
power supply that we got rid of.
Oh, I see. But the traces that we have there are all the ones we have, so we're good.
Yep.
Okay.
I wonder if we just need to add that to the schematic.
I was trying to think through how,
Let's go see if we can
if
add
we
it.
if we could just put a power pad down and give it a footprint that's your screw block, if they have such a thing.
Yeah. Let's see if we can put something on here.
Let's see if we have a device that is, a 2-pin power
Yeah.
thing of some
Let's
kind.
just see if there's a screw terminal.
Okay.
Screw terminal 1x2. Look at that. It might not be pretty, but
It is the thing we need though,
it is.
And now we label those what, 9 volt and
Yep, we connect one to 9
ground.
volt and the other one to ground.
Sweet. And we know how to do that now. We stick
Yeah.
labels on them.
Yeah, we like learn stuff. All right, this is J1.
Okay.
And we do this. You get a +9.
Awesome.
Not quite what I meant to do. Well, let's place our other symbol first, and we'll worry about making the schematic pretty later.
I think it looks good just like that.
Honestly, it's not terrible. They're going to point away from each other.
Yeah.
It does actually make explicit what we're trying to do, so. There we go.
Okay, so we give that a better name than screw terminal 01-2.
Yep. So that is J1, and we're just going to call this battery.
Sweet. Okay.
And
So
now,
update our scheme. Now we need does it have a footprint now? Did we check that?
oh geez, it's probably whatever footprint it's got. It's probably horrible. Nope. Good call.
It's really horrible.
All right. It is everybody's favorite terminal block.
Sweet.
Okay, so now we update from our schema. Oh, look at that. Looky there. Well, crud.
Which kind of crud?
I might have to rotate that 7805 around.
Okay.
But I have to rotate this anyway, so. Actually, I like that orientation pretty well. It keeps it pointing the exact opposite direction of the LED. Oh, that's 180 degrees off what it's supposed to be. There we go. Oh, look at
Okay.
that. So the ground there is sorted. The plus 9 volts almost sorted. I have to wire in a jumper. But
It those traces are run together just like that.
yeah, the 5 volts the problem.
What do you mean? Oh, I see. Yeah, it goes around that way.
Yep. So there isn't a good way around that unless I move. Maybe if I move this around to the other side. Let's try it.
Let's try it.
It's getting better. Um, I can change the way that ground is run off of the 7805. I can run it in off the top here. I run the 5 volt down here. And that comes up here. Yeah, that's actually not horrible.
Okay.
Let me rotate this clockwise. Drag it down a little bit. Yeah, suddenly that got really good. All right, so I select that trace there. I break that, break that. Oops. Yeah, as much fumbling as there was, this has gotten a lot better fast. Oh shoot. Plus 9 volts off the 7805 coming to the transistor is weird. Let me rotate the 7805
Okay.
counterclockwise and see what that gets me. That's better. Okay, I've got my plus 5 volt here. It comes off there. And my ground. Oh, my ground traces are all loopy. All right, and now I think I can just run a 9 volt. Shucks. So my ground has to cross there. Or does it? Yeah, because I have to get up to there. All right, let's. Let's rotate it clockwise again. Or counterclockwise. And that trace is obviously not a happy trace anymore. Well, now it's just a trace that needs to be moved a little bit. That was bad. Okay.
It almost worked though.
It almost did. I was very happy with that trace for about half a second. I got to zoom in here and select that trace. That trace. All right. But rotating this may give me some perspective on things. And that perspective might be that I make bad choices, but okay, ground. That ground is linking that ground to there, but that ground also links up down here.
Yeah, so you should be able to draw the ground from the 7805 up and to the right to the battery, and then you'd be okay, right?
Yeah, that's my thinking. So that's good. Now I can draw a trace from there to there, and that's good. Then I've got a trace from there and to there, a trace from there. Fork.
Go over the top with it.
Yeah, you're right. That's good. And then this finishes that trace there. All right, there's a double trace there, and I got to clean that up. But we have solved the problem.
Sweetness.
It needs to be neatened up
So
a little bit, but that's not a big deal.
yeah, there'll be little things like I think I'm not sure how it applies the rules on keeping things as far enough away as they need to be. Like I think the ground coming off out of the 7805 is a little close to that left-hand pin there. Probably needs to go up and out a little bit.
Ground off of this. Oh, so yeah, you're right. You're right. That they're touching there. That's bad. All right, I have to delete these traces, but I'm gonna sort them.
Yep.
And I need to get rid of that trace. Damn.
It's a good thing there's just an undo button and it wasn't a bottle of spilled ink on the sheet of paper there.
Yes. Some of my better expletives may have been put into use at that point. I do know sufficient bad language to make a sailor blush. It turned out not to be as hard as I thought it would be. I'm not the one who used it, though. Gonna blame that entirely on her mother, who yelled at the crowded bar in the middle of a very awkward silence.
Awesome.
All right, I think that's good there. Oops, we don't need that little trace down there. That little trace is just causing us trouble. Okay, and yet you're 100% right about this trace here. It's got to get moved. No, but we got to select that and all right. It's gonna let us drag it. There we go. We've got a little bit of clearance now.
Yeah, did let you drag it, didn't it?
Yep, you got to ask it. That's the thing I learned just now.
I missed how you asked it.
So you select it with the arrow tool and you right click, and there's drag and 45-degree or free angle.
Oh, sweet.
So we got a couple of tracks missing yet. We've got that, which has to get connected in here. All right, so they're happy. And then that one gets pretty easy. Yeah, all our grounds are good that way. That's all sorted. And then we just have to go from there to there. And everything's sorted. Save that
Super
beastie.
awesome.
All right.
So what generated those little arrows for us there?
Yeah, because we want those to go away, don't we?
Was that some of the analysis?
Yeah, that was that analysis tool. Perform design rules check. There we go. Okay, so we still got tracks too close to pad.
Okay, that's okay.
Oh, those are our old things. Okay, still doesn't like those if they're too close to pads.
It says the board edge. Where's the board edge?
Yeah, we haven't really sketched in where the board edge is.
Does it take you to it?
I mean, it took me
to it. I guess it took you to the arrow. Yeah. Okay. So, but it points them out on the board there. So it thinks the board edge is right there.
Yeah. So we're gonna close that. We've deleted our markers.
So how do we tell this thing to show us where it thinks the board edge is?
That is a remarkable question. That's all that stuff there.
Is there something in the view menu or?
There's a board setup. Oh, but this is all that stuff that I didn't really understand. Open schematic and a schema. That's not it. That PCB, load net list. A lot of plotting, page settings for paper size.
In the example I'm looking at, there's like a yellow boundary around the board.
Huh.
And I'm wondering how it
Place. Oh, footprint, that's not it.
Oh, that's probably silk screen. Ignore me. You can create all kinds of cool layers. Yeah, that's the silk screen I'm looking at.
Yeah. It's a 3D viewer. Huh? There's a 3D viewer. Oh, okay. It's like auto-sizing the board for us. That's why.
Oh, cool.
And it's definitely auto-sized it over on that side. We want it to
So
be...
how do we give it more boundary then? So it
Yeah. I don't know.
Oh, that was cool.
Yeah. Okay, so those places where it's showing the overlapping text on the board, it's really overlapping text on the board. Yeah, we're just gonna have to tell it that we want a little more room, but we'll figure out how to do that. I'm pretty happy with what we got. We could definitely print this thing and do the cheap photocopy transfer thing and burn something real off of it. And I know you can take these labels and you can transfer them to uh, you know yeah, some of the labels we're putting on things aren't showing up on the board, so we'll have to change that. But that is a problem we can
Yeah,
solve.
yeah, you're gonna want to somehow have those part of the silk screener if you're gonna do that.
Yep. Yeah, that just might be a case of selecting the right layers.
Super awesome.
All right.
Well, was that a good night's work or what?
That was a good night's work, and we're way past time, so I think we've stressed. I think we've anybody who's still watching, I admire their fortitude. But
Yeah, I wasn't gonna poke it until we got the traces squared away. So I
yep,
figured that was a better place to stop than any place else.
those traces are squared. Everything else is something I can do offline. And so I'm going to end the stream there, folks. Anybody who stuck with it this long, I commend your fortitude. And, well, you should go rest now if you're still awake.